Welcome to this video where we are going to solve our question 4 of Math 2602, which is Introduction to Statistics. Okay. Alright, so the question reads, an electric firm supplies light bulbs that have a length of life that is approximately normally distributed with a standard deviation of 20 hours. If a random sample of 40 bulbs has an average of 800 hours, okay, find the marginal of error for 95% confidence interval. Okay, so let's collect the information that we've been given there. So we've been given that the sample size is 40. Okay, the sample mean, we've been told that it's 800, and then the standard deviation, okay, we've been told that it's 20, and then the confidence interval that we are considering is just 95%. So from this confidence interval we can get the significant level. So the significant level will be 100 minus the confidence interval. So 100 minus 95 is going to give me 5%. So this significant level is usually expressed as a decimal, like 0.5, and we call this as alpha, like that. Alright, so now the first question there, they're saying find the margin of error. Okay, so margin of error is just equals to the z-score at the critical value alpha divided by 2 multiplied by the standard deviation divided by the root of the sample there. Okay, so this guy here will just be equals to z. Okay, our alpha there is 0.05, so I'm going to write 0.05, and then we are going to divide by 2. Okay, and then we are going to multiply this by the standard deviation divided by the sample size, the root of the sample size there. So now this here, okay, this here is the z-score from the z table, okay, or from the normal distribution table. So at 5% significant level is the same as 95% confidence interval. So at 95% confidence interval, the z-score is simply 1.96. So where there's z 0.05 divided by 2 there, I'm going to put 1.96. Okay, so it means our margin of error will just be equals to 1.96 multiplied by the standard deviation is given as 20 divided by the root of 40. Okay, so you punch this on your calculator, you're going to get 6.2 hours. Okay, so this here will be our margin of error. Alright, so let's write it here. Margin of error will just be simply 6.2 hours. Alright, so we've done the first part. Let's go to the second part. So the second part now, we are calculating what? So the second part, they are saying find a 95% confidence interval for the population mean of all bulbs supplied by the firm. So confidence interval about a mean, okay, is just given as mean plus or minus, okay, z alpha divided by 2 multiplied by standard deviation divided by the square root of n. So this here is the part that gave us the what? The margin of error there. Okay, so it means we're just going to say mean there, which is 800, plus or minus this part here. We already know its value is this, is the margin of error, so we're going to put 6.2. Okay, so it means that our confidence interval will just be 800 minus 6.2, which will just be 793.8. okay, 793.8, and then comma, what is 800 plus 6.2? So that will be 806.2. So what we have here, okay, is our confidence interval. Alright, so we've solved the second part. Let's solve the last part of this question here. Okay, so on the last part we have a hypothesis testing. Okay, so let's first of all come up with the null hypothesis. Okay, so the null hypothesis, let's read the question. They're saying hence tests the hypothesis at 5% significant level with the claim, okay, that the population mean life of all the bulbs supplied by the firm is 800. Okay, so it means our our now hypothesis, okay, will be that the population mean is also equals to 800. Okay, remember the sample mean is 800, so here we are trying to test if the population mean is what, 800. So it means um, our alternative hypothesis, okay, will just be that the population mean is not equal to what, 800. Okay, so this will be the test statistics that we are the test problem that we are going to have. Okay, and then since here we have an equal sign, and then here we have an the sign which is not equal to here. Okay, we are going to say this is a two-tailed test. Okay, two-tailed test. So meaning we test the left side, we also test the right side of the what, of the 800 there. Okay, so let's write down the test statistics that we are going to use here. So test statistic that we are going to use. Okay, so test statistics that we are going to use will just be the Z should be equals to the mean, the sample of the mean, okay, or the sample mean minus the population mean divided by standard deviation, which is divided by the root of the sample, like that. Okay, so since this is a two-tailed test, okay, it means our decisions are going to be based on the following. Okay, so if the Z that we are going to find here, so this should be the Z observed, so you can put it with a star there. So the Z observed, okay, if this magnitude of the Z observed is greater than the Z critical value, okay, which is given by this, okay, if this Z observed is greater than this, we are going to reject the null hypothesis. Okay, but if the magnitude of the Z observed, okay, is less than the Z critical, okay, we are going to fail to reject. Okay, so those are the two facts that we are going to use in order to reject or to accept. All right, so let's find the Z observed. Okay, so Z observed will just be equals to, okay, the sample mean, which is 800, minus the population, which is also 800, divided by the standard deviation, which is 20, divided by the root of the sample, which is 40. So we notice that what we have on top there will just be a 0. Okay, it will be 800 minus 800, so it means the answer here will just be 0. So it means the Z observed, okay, is 0. So now let's find the Z critical. So the Z critical, we already found it when we are dealing with question 1. Okay, so the Z critical here at 95% confidence interval is just 1.96. Alright, so what do we notice here? We notice that the magnitude of the Z observed is actually less than the Z critical. Alright, so if we have such a situation, we are going to say we fail to reject. Fail to reject. Okay, so we are going to fail to reject there. So our conclusion will be at at 5 level of significance, okay, there is not enough evidence to reject the claim that the population mean of all bulbs is 800. All right, so that's it for question A. Let us now look at question B. So the question reads, an auto manufacturing company wanted to investigate how the price of one of its car models depreciates with age. The company took a sample of 8 cars of this model and collected the following information on the ages and the prices as shown below. So we have this table here where we have 2 rows. Okay, so the first row here has the age, and then the second row here has the what, the price. All right, and then number 1, they're saying draw a scatter diagram and comment on a linear relationship between the ages and the prices of the cars. Okay, so for us to draw this scatter diagram here, we have to identify our dependent variable and our independent variable. So since we are talking about this depreciation here, it means that, okay, the price of these cars will be dependent on the age. Okay, so we can see here, if a car has a long lifespan like 9 years, okay, it means its price will be low like that. And then if a car has a short lifespan like 2 years, where we can see 2 there, we see that the price is what? High. So it means here the price depends on the age. So we are going to put the age on the x-axis because it's independent, and then we're going to put this price on the what? The y-axis, because it depends on the age. All right, so to plot this, we will need to have a scale for the x-axis and for the y-axis. So if I come in the first row here, I can see that the lowest number is 2, the highest number is 9. So it means my scale there, I can just use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then on the y-axis where I have the price there, okay, I can see my lowest number is 45, my highest is 267 there. So what scale can we use there? Okay, we are going to use the 50s for the y-axis there. Okay, so meaning if I come from 0, I'll go to 50, I'll go to 100, just like that. Okay, so that's what we are going to do in this question. So let's plot what we have here on the x or y plane. Okay, so let's make this a bit smaller like that. Okay, so that we may have space to plot the scatter plot. So I'm going to say this scatter plot, okay, we do have two parts, to be the y-axis this side. Okay, this is the y-axis, and then we have the x-axis like that. Okay, all right, and then from here we can label this. Okay, so this can be our 0, and then we say this here indicates the what? The edge. So this is the edge, and then up there we're going to have the price. Okay, so we said the edge, we are going to use what scale? Just 1, 2 until up to 10, right? So we can plot the points. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I have 10 like that. All right, so that's the x-axis. Okay, what about the y? We said the y, we are going to go into 50s. Okay, so I'm going to say 50 here, and then 100, okay, 150, and then 200, and then the 250 can be somewhere there. Okay, so it means here we have to increase our graph. Okay, so we're going to put our 250 somewhere there. It means this graph here has to go up a bit like that. Okay, so that will be the price on the y-axis. Okay, and then after this, now we can start plotting these points. Okay, so the first one there is 8,45. So I'm going to go on 8 here. Okay, and then I plot it against a 45. So if this is 0 and then that is 50, it means the 45 is somewhere there. Okay, so I'm going to say 8, and then here I'm going to say plot the point there. So that will be 8,45. Okay, let's plot the next one. The next one is 3,210. Okay, we can see from here it's 3,210 there. So 3 is here. Okay, then I go up to where I can find my 210. So my 210 can be somewhere between 250 and 200. So my 210 can somewhere be there. So that is 3,210. Okay, and then the next one is 6,100. So 6, and then I go to 100. So 6,100 will be somewhere there. Okay, somewhere there. Let me drop it a bit. So 6 and then 100 should be somewhere here. We can see there it's matching with the 100, right? And then here it's matching with the 6. All right, and then the next one is 9 comma 33. So 9, it means 33 has to be below 50. Okay, so 33, since midway here we're going to have 25, so 33 will be above somewhere there. Okay, so 33 is going to be somewhere there. So 9 comma 33. And then the next one is 2 comma 267. So 2 comma 267, we come onto here and then go all the way above 250. So 267 can be somewhere there. Okay, all right, the next one is 5 comma 134. So I come on 5 and then I go to 134. So 134 is between 100 and what, 150. So 5 and then I go to 134, which will be between 100 and 150. So to be somewhere there, that would be 5 comma 134. All right, the next one is 6 comma 109. So 6 comma 109. Okay, so 6 is here. Okay, so maybe we should move this point for 6, eh? Yeah, so the 6 should be in this point. So this was 6 comma 100, and then now I want to find 6 comma 109. So 6 comma 109 to just be slightly above this one here, like that. Okay, I think it has even gone up a lot, so like that. So that would be our 109, 6 comma 109. And then the last one is 3 comma 235. So 3 comma 235, 235 should be between what, 235 should be between 235, okay, should be between 250 but above this one that we drew for 210. Okay, so this is the 2 here, I mean this is the 3 here, like that. Okay, so maybe we should move this point there. Okay, I draw it not at there. Okay, so the other one was 210 when we had 3, so it was 3 comma 210. We can put it there, that was 3 comma 210. And then now we have 3 comma 235, which should be above this 210, so somewhere there. All right, so these are the points that we've plotted. Okay, so we see that they are forming a pattern. Okay, they are forming a pattern. So now I'm going to draw a line, okay, that follows those points. Okay, so this line will just be like that. Okay, so we see that these points here form a pattern. Okay, they have a line that they are forming. So this line that they are forming, okay, will help us find the relationship that it has. Okay, will help us find the relationship that it has. Okay, so this is the scatter diagram that they wanted us to plot. Okay, so just plot all these points that you've been given there. So we've plotted all the points, and then when you draw a line, okay, among those points, we see that the relationship there will be a what, a negative linear relationship. Okay, so this will be negative. Why? Because we have a slope going like that. Okay, so the negative, there will be a negative correlation, okay, for the variables there. So we are going to say from the plot, the variables are negatively, okay, negatively correlated. Okay, we have a negative linear relationship. Okay, if you want, you can write negative and then linear, okay, relationship. All right, so this is the scatter plot. So we go to the next question now. They are saying estimate the linear regression line. Okay, estimate the linear regression line. Okay, so how do we estimate the linear regression line? Okay, so the linear regression line is given by the formula, okay, x cap is equals to alpha cap, okay, plus beta cap, and then x. So this here gives us the linear regression line. So it means we have to find the a cap, and we also have to find the what, the b cap, and then we just replace them into the formula for the linear regression 9. So we can see from what we've been given here, okay, that the b cap here, okay, let me choose red, the b cap here is given by the summation of xy divided by the summation of the xx there, okay, and then we have this big formula, okay, that we are going to use. Okay, the top part here we are going to use it to find the summation of xy, the down part we are going to use it to find the summation of x. Okay, and then how do we find the a cap? A cap is simply given by the mean of y, okay, minus the b cap that we are going to find from here, and then multiplied by the mean of x. Okay, so we can find all these values from the calculator, but since it's online, I can't show you that, so I'm going to find them manually. Okay, so to this table that we can see that has age, which is the x, price, which is the y, I'm going to add a few more rows. Okay, I'm going to add a few more rows. So the first row there, I'm going to say that is for xy, and then I'm going to have another one for x squared. Okay, then I'm going to have another one for y squared. Okay, so let's put it. So I'm going to have another one for y squared. Okay, so let's find now these values. So this one here will be like this. So here I'm going to have the xy, so meaning I'm going to be multiplying 8 multiplied by 45, then I get an answer there. Okay, and then here I said I'm going to have x squared, so I'm going to square all the x's, and then here I'm going to have the y squared like that. Okay, so let's divide this table into the boxes like that. Okay, let me get a straight line there. Okay, let me get a straight line. So we're saying this one here goes like that. This one here goes like that. This one goes like that. Okay, so this is what we have, right? So let's start multiplication. Okay, let's start multiplying. So we are going to start from the xy there. Okay, we're going to start from the xy. So we're going to say the first one will be 45 multiplied by 8. So 8 multiplied by 45, I'm going to get 360. Okay, and then 3 multiplied by 210, I'm going to get 630. Okay, and then I have 6 multiplied by 100, I'm going to get 600. Okay, and then here I have what here? I have 9. Okay, so 9 multiplied by 33, I'm going to have 297. 2 multiplied by 267, I'm going to have 534, and then I have 5 multiplied by 134, I'm going to have 670. Okay, the next one will be 6 multiplied by 109. So 6 multiplied by 109, it's giving me 654, and then 3, okay, 3 multiplied by 235 is giving me 705. Okay, so counter check these values here with your calculator as well. Okay, and then at the end here we're going to find the summation of the xy. So we're going to put summation of the xy is just equals to, we're going to add all these numbers that we can see in this row here. Okay, so I'll start with 360 plus 630 plus 600 plus 297 plus 534 plus 670 plus 654 plus 705. Okay, so when I add all that, I'm getting 450 as my summation of xy. Okay, let's now find the x squared. Okay, so 8 squared, it will just be what? 64. Okay, 3 squared to be 9, 6 squared to be 6, 36, 9 squared to be 81. Okay, to be 81 there. And then what else? The 2 squared before the 5 will be 25, 6 will be 36, this will be 9 here. Okay, wonderful. So now let's find the summation of this x squared. So summation of x squared will just be 64 plus 9 plus 36 plus 81 plus 4 plus 25 plus 36 plus 9. So there I'm going to get 264. Okay, I'm going to get 264 there. Right, let's find the y squared now. So the y squared, we're going to square this 45 to 10 just like that. So 45 squared, okay, I'm getting 2025. I'm getting 2025, which is this here, right? Okay, and then the next one is 210 squared. So 210 squared is giving me 44 100. Okay, the next one will be 100 squared. 100 squared is going to give me a 10,000. Okay, 33 squared, what is it going to give me? Okay, 33 squared is going to give me 1089. And then 267 squared is going to give me 71289. Okay, and then what is next? 134 squared. 134 squared is going to give me a 17,000. Okay, 956. All right, and then the next one is 109. So 109 squared, it's giving me 11,000. Okay, 881. Okay, and then from there let's find the 235 squared. So 235 squared is going to give me 55,225. Okay, so here let's find the summation of y squared. Alright, so summation of y squared, we are going to add all that we can see. So 2025 plus 44100 plus 10000 plus 1089 plus, okay, so 1089 and then plus I have 71289. Okay, plus I have 17,956 plus 11,881 plus 55,225. Okay, so when I add that, I'm getting this as my summation of y squared, 213,565. So please counter check if I found the correct value there. Alright, let's also find the summation of x here. So summation of x will just be equals to, okay, so we're going to add 8 plus 3 plus 6 plus 9 plus 2 plus 5 plus 6 plus 3. So when I add those, I'm getting 42. What about the summation of y there? So summation of y is going to be equals to, okay, so we're going to say 45 plus 210 plus 100 plus 33 plus 265 plus 134 plus 109 plus excuse me, so plus 109 plus 235. Okay, so when I add all those, I'm getting my summation as 1133. So it means now I have everything that I need in order to find my linear regression line. So let's first of all find the b cap. Alright, so now we are going to find the b cap. Okay, since we have everything that we need now, so we are going to say b cap is equals to, and then we are going to use this big formula that we can see here. Okay, so in the numerator there, okay, we have the summation of x, okay, we have the summation of xy minus summation of x multiplied by summation of y divided by n, and then in the denominator we have the summation of x squared minus summation of x squared divided by n. So what is our summation of xy? Okay, summation of xy, it is this value here, which is 450. Then I'm going to say minus the summation of x in brackets, it is the 42. Then summation of y, it is 1133. Okay, and then I'm dividing this by the sample size. So the sample size is n is equals to 8. So I'm dividing this by 8, and then we are dividing by, okay, the summation of x squared, which is 264, minus the summation of x, and then we square it. So summation of x is 42, and then we're going to square it, and then we're going to divide by 8. Okay, so from there, what are we going to have? So on top there, when I punch on my calculator, okay, I'm getting minus 1498.24 divided by, when I punch this 264 minus 42 squared divided by 8, I'm getting 43.5. Alright, so when I divide this, I'm getting minus 34.44. So this here will be my B cap. Okay, so once we have our B cap, we can use it to calculate the what? The A cap there, or the alpha cap. So let's move our B cap a bit above there. Okay, so we are going to say our B cap is this. Let's move it here. Okay, we're going to say this is our B cap. Since now we have our B cap, we can use it to find our what? Our A cap. So our alpha cap will just be equals to the mean of y minus B cap x, the mean of x there. Okay, so how do we find the mean of x? So mean of x is equals to the summation of x. Summation of x is 42, and then we divide that by 8. Okay, so what will be our mean of x there? So you just go on your calculator, okay, and then you punch in the value 42 divided by 8, which is going to give me 5.25 as my mean in terms of x. What about my mean in terms of y? So mean in terms of y is going to be equals to the summation of y. Okay, summation of y, what do we have? We have 1133 divided by, okay, 8. So 8 divided by this 118 is going to give me what? It's going to give me 141.625. Alright, so since I have the mean in terms of the y, I also have the mean in terms of the x, I can replace in the formula for the A cap there, or for the alpha cap. So we're going to say alpha cap is going to equals to, okay, the mean in terms of the y is just 141.625 minus, okay, and then the B cap, we found it was minus 34.44, and then we are multiplying this by the mean in terms of the x, which is what? 5.25. Alright, so when we multiply that, what are we going to get as my A cap, or my alpha cap? So my alpha cap will be equals to this minus 34.44 plus 2 multiplied by 5.25. Okay, so that is going to be 144.625 plus 180 plus 82. 180.82. So when we find the total here, it's just going to be 322.45. Okay, so this will be my alpha cap. So since now we have our B cap, okay, we also have our alpha cap. Okay, it means we can find this line of what? Linear regression. Okay, so our line for the linear of regression will be, so let's write it down here. Okay, we are going to erase that. We're going to say, okay, we're going to say our linear regression line will just be y okay, is equals to, okay, it's going to be y cap is going to be equals to the alpha cap, which is 322.45, and then plus the b cap, okay, which is minus 34.44, okay, and then multiplied by x. So it means my linear regression line will just be equals to 322.45 minus 34.44x. Okay, so that there will be our line for the linear regression. Alright, so we are done with this question here. We move to the next one. Okay, so to the next one here, they are saying test the hypothesis, okay, that b is equals to 0 against the alternative that b is not equals to 0, okay, meaning that either there's a significant linear relationship between x, okay, and y, or there's no relationship at all. So they're saying use either the f test, okay, or the t test at a significant level of 0.05. all right, so here I'm going to use the f test. Okay, I'm going to use the f test. So for us to use the f test, okay, we are going to come up with the hypothesis first of all. Okay, we're going to come up with the null hypothesis. Okay, so what will be our null hypothesis? Okay, what will be our null hypothesis? Our null hypothesis, okay, or we can say the testing problem. So we are answering question 3, right? Okay, so we are using the f test here, specified using f test. So it means our testing problem, okay, testing problem will be the null hypothesis, which is h0, will just be that the b is equals to 0, and then the alternative hypothesis h1 will be that the b there is not equals to 0. Okay, so it means that we have to find the value of the f observed. Okay, so the f observed, we have to find this value. Okay, so if your f observed, okay, if your f observed is greater than, okay, the f from the question, okay, so we put the alpha there and then 1 comma n minus 2, like that. Okay, so these are the degrees of freedom. So if your f observed here is less than the f alpha, and then in the brackets we have 1 comma n minus 2, okay, if it's greater than that, okay, if it's greater than that, then we have to reject the null hypothesis. Okay, we have to reject. If it's less, then we will fail to reject. So what is the f alpha and then 1 comma n minus 2? Okay, so I'll write here. So our alpha is 0.05, and then in the brackets the degrees of freedom will be 1 comma n minus 2. So our n, we are dealing with 8 samples here, so our n minus 2 will just be 1.6. right? So if I find this value, okay, from the f table, okay, if I find this value from the f table, it will be 5.99. So what we have to do here is now find the value of the f observed. So this value of the f observed, we are going to find it from the ANOVA table that I've given here. Okay, so this is the ANOVA table on top there. Okay, so in this ANOVA table we have different quantities, okay, that we must be aware of. Okay, so we are going to have 4 columns in this ANOVA table. Okay, so the first one will be the source of the variation. Okay, so we have 2 sources of variation. We have the regression one and the error one, and then the second column will be the sum of the squares. Okay, so we have the sum, the regression sum of squares, which is represented by SSR. We also have the error sum of squared, which is represented by the SSE. Okay, and then the degrees of freedom will be in the third column there. So this regression here, okay, the regression always have the degrees of freedom 1. Okay, and then the error there will have the degrees of freedom n minus 2. And then here where you can see SST, that SST is the total sum of squares, okay, meaning you add the regression sum of squared plus the error sum of squares to get this. So this total sum of squares, okay, has the degree of freedom n minus 1. All right, and then the fourth column here has what we call as the mean squares. Okay, so we have the regression mean square or the mean square regression, and then we also have the error mean square or the mean square error. Okay, so how do you find the mean square regression? The mean square regression is the same as the regression sum of squares. So the value that we are going to put here, okay, it will be the same for the mean square regression there. But how do we find the mean sum error? Okay, I mean the mean square error or the error mean of the squares. Okay, we are going to say that one, this one here, we calculate it by dividing the error sum of squares divided by n minus 2. And then this f observed now that we want to find there, okay, will just be equals to f observed will just be equals to, okay, the mean square regression divided by the mean square error. So this is what we have to find there. Okay, so I'm going to erase all this so that we find those SSR, okay, the SSE, all those that we can see from there. Okay, so the SSR, okay, we can start with the SST there. So the SST is the total sum of squares. Okay, so how do you find the total sum of the squares? So the total sum of the square is the same as the summation of y, and the summation of y will be given by, okay, summation of y squared minus summation of y, and then you square it divided by n. Okay, so what is the summation of y? So the summation of y, when we come here, summation of y is what? I mean the summation of y squared is this. Okay, so there should be a 5 at the end like that. So summation of y squared is 2, 1, 3, 5, 6, 5, okay, minus the summation of y squared. So summation of y is 1, 1, 3, 3, and then squared, and then we are dividing that by n. N is 8, right? Okay, so let's find the SST. So SST will be equals to what? So you go on your calculator and then you punch in that value there. Okay, so let's find that. Okay, so we have 1133, and then let's square it. Okay, and then we divide that value by 8. So if I do that, I'm going to get, okay, this one here remains the way it is, and then the other part there will be minus 164.61.125. Okay, so when I do 1133 squared and then I divide by 8, I'm getting this value. So make sure you counter check with your own calculator as well. So let's find now the difference between this number and this number there. Okay, so we are going to say 2135, okay, 65 is going to give us what? Okay, I mean 213565 minus I have 160, okay, 461.125. Okay, so from there I'm going to find my SST as 53.1003.87 So this one here will be my SST. So I'm going to write it somewhere on top here. So SST will just be equals to 53. Okay, my screen is not allowing me to write that side, so I'm not just going to write it here. So SST will be equals to 53103.875. So that is my SST. Okay, so from the SST we are now going to calculate the what? The SSR. So the SSR is given by this formula. Okay, we have B cap multiplied by xy. Okay, so we are going to say this is equals to, what was our B cap? Okay, so our B cap from the previous page we found it was minus 34 3.44. Then we are multiplying this by the SXY. So SXY, we found it was this. So we are multiplying by minus 1498.25. So this will give us our SSR. So it means our SSR will just be a product of those now. So it will be minus 3.44 multiplied by minus 1498.25. So when I multiply that, I'm getting 51.599.73. So this will be my SSR. Okay, so I'm going to write my SSR here. Okay, so it will be 51,599.73. So this will be my SSR, and then on top there I should have my SST. Okay, so I don't know why I wrote a T there. Okay, so on top there we're going to have my SST, and then there down we have our SSR. Okay, and then from there we are going to find our SSE. So remember we said our SST was just a summation of our SSR plus our SSE. So it means our SSE, okay, will just be equals to SST minus SSR. So this here will be our SSE. So our SSE will be, our SST is just 53,1003.875 minus our SSR is 51,599.73. So let's subtract this to get our SS what? E. Alright, so make sure you counter check these values with your own calculator as well. So 53,1003.875 minus 51,599.73. So when I subtract that, I'm getting this as my answer. Okay, I'm getting 1505.145. Okay, so this is what I'm getting as my SSE. Okay, that will be my SSE 1504.1145. Alright, so let's write our SSE here. So SSE will just be given by 1504.145. Alright, so once we have those now, we can calculate our regression mean, our mean square regression. Okay, so our mean square regression, since the degree of freedom there is 1, okay, since the degree of freedom here is 1, it means our mean square regression will be equals to our regression sum of squares. So it means my MSR will just be equals to my SSR. Okay, so our SSR is given by 51,599.73. Right, and then from there, what are we going to do? Okay, from there we're going to find our mean square error. So our mean square error is given by the error sum of squares. Okay, so the error sum of squares is 1504.145 divided by, okay, n minus 2. So n is 8 and then minus 2, that is 6. So let's divide that number by 6. Okay, I'm going to get the following. So I'm going to get what? I'm going to get 250. Okay, I'm going to get 250.691. Okay, so I've rounded this to three decimal places. So that would be my MSE. So my MSE is just 250.691, and then we said our MSR is just the same as SSR, which is 51,599.73. Alright, so once we have those now, we can calculate our F observed. So our F observed will just be equals to MSR which is 51,599.73 divided by MSE. So MSE is 250.691. Okay, so our F observed will just be equals to what will be our answer there? Okay, our F observed will just be equals to 51 point okay 51 point 599.73 divided by 250.69. Okay, so when I divide that, I get my F observed as 205.83, like that. Okay, so we see that our F observed is actually, it will be greater than the critical value, the F of the critical value. Okay, so remember F of the critical value, which is 0.05, and then we have 1,6 was just given as 5.99. Okay, so 5.99 is actually less than this, so we see that our F observed is greater than what? The F.05 and then 1,6, like that. Okay, so this is what we get. Our F observed is actually greater than this, because here I can see 205, here I can see 5.5. Alright, so it means we are going to reject the null hypothesis. Okay, we're going to reject the null hypothesis and conclude that there is a significant difference. Okay, I mean there is a significant linear relationship between the x and the y. Alright, so we are done with that one. Let's calculate the last one. So the last one, we are calculating the coefficient of determination. So coefficient of determination is equals to SSR divided by SST. So SSR is just 51599.73, and then I'm going to divide this by SST. So SST is what? SST is 53,103.875. Okay, so let's divide those. So we have 51,599.73, I mean, divided by 53,103, and then 0.875. Okay, so when I divide those, I'm getting 0.97. I can just round it off to 2, like this. Okay, we can even multiply this by 100 to put it into a percentage. It will be 97.2%. Okay, so what does this mean? Okay, what does the coefficient of determination mean? Okay, so it means that the model explains that 97.2% of the variability in the car prices is caused by the car age, or is based by the car age. Okay, so that will be our interpretation of this coefficient of what? Determination. All right, so it means it's the end of this question. Thank you so much for watching. Remember to subscribe to this channel for more videos.